Hello, everyone. Thanks for joining this webinar for today. And today we have a very amazing speaker with us. He's doing our first webinar with us. His name is Jay, and he's in the product team here at SingleStore. He's a senior product manager here. And today's webinar is also a very special webinar. It's called Detecting Anomalies in SingleStore using audit logs using AI. So this is a unique topic that we are bringing to you, and it's honestly like our first time covering it like publicly, because SingleStore has had these capabilities, but we never really it was more like, it was tailored for the customer like that requested for it, so never really showcased it publicly. But today we are kind of unveiling it, and Jay very kindly agreed to do a webinar with us. So thanks so much, Jay, for for all the effort that you have put into this, because I know how much energy and time goes into it. So yeah, so Jay is working on this particular feature, and if there's any questions, any feedback, you can communicate with us using the Zoom Q&A button, which is present at the bottom of your console that you can see, because you're currently in a listen-only mode. So, and we are obviously, going to do a dedicated 10-minute Q&A session. So keep your, you can always put in your questions using the Q&A button, and we'll obviously take it up either during the session or towards the end of the session, depending on the question. And yeah, keep an eye out for the chat button, because SingleStore gives away $600 worth of free credits that can help you easily get started. It does not like when you first sign in, and it does not really require any credit card details or any of your information assets. So feel free to play around with the product as Jay walks you through the features. So yeah, like that way you can make the most out of your time. And as for me, I'll be your host for today. I'm Yukti, and one of my main jobs here is to bring these webinars to you. And so yeah, you can explore SingleStore, and yeah, like have its new scoop of what we bring to you. So yeah, Jay, please take it away, and thanks everyone for joining.
Okay. Thank you, Yukti, and hello, everyone. This is Jai Bhatt. I'm a staff product manager for security at SingleStore. I joined last year, and before that, I have 20 years of experience in different capacities in the product management. And today, we will talk about how to use AI to kind of segregate the audit logs and kind of get the insights out of the data. So, welcome everyone again, and if any of you are already using SingleStore or any other database, then you know that you know how important the audit logs are. Those who are not familiar with the audit logs, basically it keeps track of what is going on, who does what, when, from where, the things like that. It keeps track of and kind of helps in keeping a tab on, malicious activities or kind of activities that you would normally consider as privileged. So due to the nature of the database and the heavy usage, everyone knows that there are hundreds of thousands of lines of logs, or the volume size of the logs increases dramatically. So what we call it here is audit fatigue. So when you sniff through the audit logs, it becomes very tedious and it becomes very hard to kind of filter out the signal from the noise. So how do we kind of uh, address that problem of audit fatigue? So today, in next 1 hour, I will take you through that journey where we will, try to replicate that scenario where someone is trying to do some malicious activity and it appears in the audit log, and then using AI, we try to detect that, right? So that's the purpose of this call. And I, even though there is a slide, but I will try to keep it as short as possible so that we can see the action in real time and make you make the most out of the webinar. So yeah, with that, let me go to the next slide. So yeah, so as you know that before we talk about the audit logs, so just a slide about a SingleStore. So it's the only database that provides hybrid transactional and analytical database, and it that provides contextualized data in the real time. So when we talk about the real time data and processing it and analyzing that data, so even our audit logs gets generated in the real time, and the speed of generation of this data, audit data, it kinds of massive. And with that, it also increases the expectation that we should be able to figure out the activity going on within the database or within the ecosystem at the same speed. So how do we do that? And we'll talk about that. But on the if we focus on the single store, then there are versions to it. So there is a managed single store where single store hosts a database and provides you the cluster and provides you a control plane to manage all the clusters and database. Or if you are a single if you are a self-managed customer, or if you are using a single store database in your environment, then there is a self-managed edition, and you can use that on-prem, or you can also bring your own cloud. So depending on that, your focus could be on. So if you are using a self-managed version, then you will be mostly focusing on the database activities. But if you are using the Helios managed services, then you need to take care of the control plane, which is a portal to kind of manage the clusters and users and add their access control and the database, of course. So you will have to focus on both sides. So uh, yeah, then we will also see that for the control plane, your focus would be on that who is logging into the portal, who is making changes into the firewall, like allowing access from different IP address, and who changed that or why they changed it, who created new user, or someone generated an API key with a broad permission, who could using which you can do some malicious activity. So the risk is more on the intruder side. So let's say someone is trying to hack into your portal and then do some stuff. And the second one is the data plane, which is the actual database. So there your focus is like someone has already gotten inside your network and he's trying to do some malicious activity with your data, right? So running some risky SQL queries, and then kind of trying to grant some broad permission, or dumping the data out of the database into a local file and things like that. So uh, this is something we have to be mindful that what all activities we have to kind of sniff through the audit logs, because audit logs, depending on what level of logging you have enabled, it could log as simple as login, log out, to your deepest, or your raw SQL queries and the errors. So we have to understand that what is it that we want to watch out for. Then false positive trap. So how so means before AI, how we have handled this problem? So we normally use SIEMs, right? So those who doesn't know CM, so basically it's a security information and event management systems. So there are tools or vendors available like Splunk, or CrowdStrike, or Exabeam. So they where we dump all the logs from all the entire ecosystem, and then those tools kind of keep track of all the logs and kind of matches the some pattern. Like let's say if someone used the drop table query, then it will flag that okay, someone tried to drop a table, and then since that word matched, it will kind of generate an alert, and then a person or an admin kind of take a look at that alert, and then kind of take an action, whether it's genuine user dropping a table, or someone tried to sabotage certain activities within the database. So the problem with the standard situation, and by no means I'm against the CM. It's very good for compliance and storage purpose. But when it comes to sniffing through the entire lot of data, it's just a pattern matching system which does not understand the context. And that's so when we talk about the context, so that's where the AI comes in, right? Because AI context is king. So what context you provide, it understands it, and it kinds of uh, uh, boils down to the real matter, which really is important. For example, if someone is trying to log in, so even simple activity like login, it could be a security threat if it is happening outside of the office hours, or if it is kind of happening from a location which is not kind of which is unusual. So things like this is understandable only through the AI, which is not very easily kind of mapped to static patterns that we use in the SIEMs. So yeah, that's why AI wins, and we will see that how it is used. So one thing to keep in mind is like when we try to talk to machine through AI. So, AI is again a software, and it depends on the instruction that we provide. So the more standard instruction that we provide, the better the output will be. So normally there should be a structure into the instruction or the context that you pass, like what role the AI has to play, and what is the context, that what it is looking at, in what format, and what it is supposed to find out. And then if you provide some structure data, then it can easily identify the input as well as the output that it generates. It will be much more structured and consistent. So this is something we have to keep in mind. I will show that in a moment, once we go into the demo. Right. So let's go into the actual hands-on. So what I will be doing is that in the first part we will just go to the control plane, and we will see means we'll fetch the audit log and then analyze it. And then in the second part we will do the same activity on the database side, so that you can cover both the parts. And before I show you the code and the scripts and everything, so I just wanted to kind of um, take you through this diagram, which kind of visualize the entire process. So this is for the control plane side, audit log analysis through the AI. So how it works is that, let me just turn on the laser for you to focus. Yeah. So through the SingleStore supports management API, using which you can access the audit logs. So we will use that API to kind of fetch the audit logs. And once we have the audit logs from the server, then through a Python script that we have developed, we will try to um, fetch it and put it onto the local computer. And the output is in the JSON file, and it will have different fields and activities related information. We will see that. And then once that file, audit log, is available onto the desktop, then we will use another file to kind of analyze that particular log file through the AI. So the way we are using AI is that we are using AWS Bedrock to kind of use the different AI models. So we are going to, even though it's written Sonnet 4.5, we are going to use Opus 4.5 model to analyze the audit log line by line, and then kind of we get the output, and that output will be analyzed against the context that we have set, and then it will be presented into a sample HTML dashboard where we can see the overall score and what's the verdict out of it. So this is a simple process that I will take you through, just to kind of make it easy to understand what I'm going to show you. So let me come out of the presentation mode, and I will open my terminal. So let me just clear this thing. Okay. So I'm just going to show you a list of files that are there. Let me open first files here on the Visual Studio. So first file that we are going to take a look at is the Python script, which, as the name suggests, it's going to fetch the single store control plane audit logs. So let me just run that. It does nothing, but it just calls the single store management API, and will fill the audit log into the local file system. So let me just do that quickly. Right. So as you can see that it has started fetching the log files. And since I had given the timestamp of 5th of February, that is today, and from, let's say, uh, timing of 13:55 in UTC, so it will fetch all the logs and it will put it in a audit logs.json file. So that same file is open in here. You can also open it from here. Right. Right. Okay. So here we can see that the audit logs files are, or audit logs are fetched from the server, and we can see different activities like, user login token refresh, and which means what is the user ID or the email address, or from where he is accessing from the portal or through the API, who is the user and what he is doing, right? So uh, things like this we can so in means ideally we have to feed this log into a SIEM, but today we are going to analyze it through the AI. So there is a another Python file that we have used. So it does is that it will take an input of the audit log.json that we just saw, and it will feed into the cloud code through AWS Bedrock API, and then it will kind of analyze that. Now, to understand it, that how it will be able to analyze different things that we want to kind of figure out from the code or from the logs. So here we have to kind of set the prompt. So just like we use prompt in our AI chat based interface, here also we have to kind of use some prompt, and using that prompt, AI model will kind of analyze the log entry that we have. So just for this webinar, I would try to kind of identify that, okay, highlight those activities which are kind of disruptive in nature, or which are temporal anomaly, or there is an email risk. So for example, if there are any events which are like, there are features on the single store where you can create notebook, but if you delete a notebook, then it's like a someone is deleting or kind of purging your data, or someone, if someone changed the firewall rules, or they terminate the cluster, or things like this, which is more crucial for your company or your operations. You can list them down here, and if something matches from there, it will highlight. Second check is that if the activity is being done, it is after business hours or not, because that's also important. Because let's say my organization works 9 to 5 in IST time zone, but if something is happening on the data side after the office hours, then I want to know that and flag that. Same thing, if the email address are known, then that's okay. It's of a lesser risk than someone is some other unknown email address from another domain is kind of doing some activity. So I want to analyze that. Now I'm kind of first setting up the role for that particular AI, that you are the lead database security analyst at SingleStore, so that it understands that, okay, the context is SingleStore, and is a kind of expert at the database security. Then we have to assign the mission to the AI, like you conduct a security analysis of the control plane audit log, and you use all the dimension that we talked about here. So you use that, all of them, and every means all of them are important. And then you have to kind of score them, score the each of the risk based on the nature of the finding, plus how many findings are there. Like, if you are just deleting a notebook, then okay, there is a low risk. But if it is being done after office hours, then it's probably medium risk. And if it is being done with the help of email address which looks suspicious, then it's a high or critical risk. So things like this, it will be analyzing and assigning the risk score according to that. And then once he does that, then kind of create a dashboard, and then update the entry of its finding. So we are going to kind of, let's say, just quickly run that. So let me first show you the logs. Right. So initial, there are logins only. So I'll just remove certain login tokens, so that, because otherwise it will just keep on showing you the login tokens only. Let me just remove certain login activities. Then let's see what happens, right? Okay. Now I'm going to run the analyze Python script, right? So what it does is that it starts reading the log entries, and then it will be sending it to the AWS Cloud Code AI model, and then it will be returning the response, and at the same time it will kind of start updating the dashboard. So this is the simple HTML dashboard that you could create. Of course, for the production grade system, you will have different systems for doing each of these activities on the runtime. But for this webinar, this is like a sample dashboard that I've created. What it does is that each of the line that it is kind of parsing, so it kind of lists down that, okay, what was the timestamp of that activity, who did what, what action he took, and then from where he is taking that action, what's the risk, and threat vector is authentication, and what's the AI analysis. So it says that this is a normal routine login token refresh, which is done by a legitimate single store user and during the business hours. So there is not much of a low risk, not much of a risk, but there is a notebook delete operation. So here we can see that notebook delete event is detected, and the user ID is also a UUID rather than a normal user. So there is a higher risk than a regular one. So likewise, each of these activity being scanned and analyzed. So let so this is kind of a log that's there already on the system. What next we will try out is that we will using my user, we will do certain activity on the portal, and then we will see that if it's able to kind of flag that out or not. So for that, I'll just stop this. We will go to the portal. So this is a single store portal. You don't have to kind of, if you are not familiar with the UI, then it's also perfectly fine. You just see that as a certain system where me being a malicious actor trying to disrupt certain activity, means disrupt certain operations. So there are certain workspaces. So it's already running. So what I will try to do is that, let's say I will resume something, and then I will terminate something. I will try to um, change the firewall logs as well, firewall rules. Let's just get it completed. Okay, it will happen in its time, and I will also try to terminate a workspace. Taking time, but please allow me some time. I will just select one workspace, and then yeah, uh, let's switch to security tab. We will, okay, sorry, firewall tab, and then we'll try to update the firewall rules. Okay, let's change this rule to allow access from anywhere, right? Just for the sake of demo. Then later on I will update it. Now what we will do is that we will again fetch the logs. I'm just running the same script again so that it fetches the latest data. Okay, it's complete. So let's take a look at the data again. At the end, we should be able to see the activity that we have done. So here we can see that it's my email address and activity that we did, right? And the login action that we did. So let's try to remove certain other earlier logs. so that we don't have to wait for AI to complete analysis of each and every log, right? So that's why I'm just removing other entries, and we just want to see our activity being flagged. And then we run the analysis of the same logs. Then we keep a look at our dashboard. So during the, if you implement this in the production, then, it will be happening 24/7 in the background, and it will be analyzing it in real time, more scalable manner. So someone deleted the notebook, so it flagged that. Then some person logged in, it analyzed. Then I logged in, so it's kind of analyzed, and, you know, so that it's whether it is beyond office hours or not. And then as I did the firewall rule update, right? So it says that it's a medium risk activity. Now what I'm gonna do is that the analysis is completed, but what we are going to see that is, let's say the firewall rule update, right? What we are going to do is that let's change this email address to some, you know, uh, suspicious looking email address. And we will also change the timing to, let's say, beyond in late evening. And then we'll save that, and we will again analyze the same data. So this is just kind of, simulating the live attack. And then we will see that, how it gets flagged. So earlier we saw that the activities were kind of being flagged as medium risk. Ideally, this should get flagged as a, high risk activity. Then comes another login, and then the firewall role update activity. This is a single machine operation, but you could parallelize it with multiple threads. So as you can see that, now the severity of the same activity is changed, because it says that firewall rule update itself is a risky activity, and it is being done by a highly suspicious Yahoo email masquerading as Bank of America support during late evening hours, with unspecified user type indicates likely a credential compromise or social engineering attack attempting to modify network perimeter controls or unauthorized access. So we didn't have to kind of, tell to analyze it in a different way. Just by changing the data, it understood that, okay, now, firewall rule update activity is of higher risk because of certain other context that is there. So this is where the, AI is power, and we can leverage that power to analyze any other things. Even you can see, set a context that analyze if the this kind of user did this type of activity earlier or not, whether it's historically, proven, or this is something new that he is trying to do, things like. So as many things that you have, you have, or you kind of believe that is important for your organization, you can set all those rules in your AI instructions, and then it will analyze all those logs. So this is more like finding out the suspicious activity on control plane. Now kind of we will move to the, database side, that, what all things user could do, and we will try to figure that out using the AI. So for that, what I have done is that I have installed a single store database on a, Docker. It's a container system. So I have installed that database, and then I'm going to access that database using a MySQL workbench. So let me see if this is working. So for the demo purpose, I have already created certain tables and database. So on the database credit card, I have created two tables, simple cards and users. So if let's take a look at certain data. Yeah. So this is dummy data that, okay, this is a credit card table. credit card database and simple cards table, there are certain users and their credit card numbers are stored. And similarly, under the users, there is a certain users and their passwords are stored. So now let's say if we assume that uh, let me first try to see that where is the audit logs file. So on the container side, there are audit logs stored, and depending on the date and time, there are different audit logs file being generated. So most recent file is this one. So we'll use that. If you can edit that, and it will show you different activities being performed there, and it keeps on noting it down. So as you can see that there are various entries, and not many of those entries are of interest because these are like internal information schema related activity going on, or there are other messages being logged due to the logging level of the system. And what we want to kind of sniff out of all these activities, that the risky activity that we just talked about, right? So this is the file. What we will do is that let's assume that I am a hacker, or I'm an intruder into the ecosystem, and I got access to this database somehow. So what I will do is that I will first change my database to credit card, and then I will try to see that what all credit cards are there. Just by looking at the name of the table, I'm assuming that it will be having some credit cards, and let's say, oh, I got the access to the credit card for different users. Or if I don't have access to directly the that particular table, so what we can, so there is a attack called SQL injection, or so there are types of SQL injection, and you can run different queries to get the sensitive data, so bypassing certain passwords. So even though I'm not passing any password here, as you can see, password is blank, but if you just append the query with simple one equal to one, that which always passes, so database returns the data. So things like this kind of becomes risky, and these are like standard patterns for SQL injections. So here you get to see the user's password stored into the database. Or if, let's say, if I try to create a new user, and I kind of give him a very broad permission, so these are like give privilege on all the databases, all the tables to this particular user. So these are the kind of things which are considered risky in terms of the database. Or if I am trying to let's say trying to dump this data. Let's say I'm extracting this credit card data, and then I'm storing it on my local file. So if I run this type of activities, then all these activities gets captured into the file here. So let me reopen that file, and then I'll just copy everything, and we will take it into the our. So there is a file called audit log. Here we will paste that. I'll open it in VS Code. Right. So I'll just remove the earlier file that I had used, and then I will save this. So as you can see that the content is really overwhelming, and we feed into the system. Even system has to go through each line by line and understand that what's going on to really sniff out the risky actions. So the thing that we did just some time back, right? So uh, that command is captured here, that some root user did select star from users, and then he put that data into a file user dumps.csv here. And before that, we tried to kind of run certain other grant star.star on this user, and we started doing that from here. So I'll just keep the logs. uh, Let me just see from where do we keep the logs, and rest we will remove. Yeah, we started using the credit card database, right? So other data, let's keep certain things, and then just remove everything else for the sake of this webinar to make it shorter. Yeah. I'll save this file. So here we don't have to fetch the log through a script because it's already available on the system. So you can run similar AI stuff on the system where you are collecting these audit logs from the database engine, right? So let's see. Now there is another file. I will show you first that through the VS Code. So there is another analyze um, data plane audit logs file. So what it does is that the same thing that it will, take audit log file as an input, and it will send to the AWS Cloud Opus model to analyze this file. And the the main difference here is that the prompt that we are using, so we have to tweak it to match the context that we are into the database and what all things matter for a database activity. So again, I'm setting up the role like you are the lead database security analyst at SingleStore. Your mission is to kind of do the forensic analysis of the audit logs and go through all the checks, and all checks are mandatory. The log format is this so that it understands the log format, like first field will be timestamp and second will be user, IP address, event type, query. Then a I've also given this sample log entry so that the more context you provide clearly, the better the output will be. So there are various best practices available online to for prompt engineering. So follow that and your results will be spectacular. So here what we are asking him to check is that first dimension to check is that integrity and injection attacks, SQL injection, right? So check if query contains injection patterns. you know Even with injection pattern, AI is smart enough to understand that, okay, what all things can go in the SQL injections. Uh, are there any, indications of bypassing the logic, or if we are escalating the privileges by granting broad permissions, or there is a confidentiality and exfiltration. So we were trying the into output file or into S3 or other storage areas where means where hacker might be putting up the data. Then availability and sabotage. So if I'm trying to drop certain database or drop certain tables, I don't want to steal the data, but I just want to sabotage or make some outage in your organization. So then certain commands which kind of have that effect, I want to log them and kind of see them or flag them. Then defense evasion, like if what if a hacker goes there in the system and then just first turn off the audit level itself so that there are no audit logs. So I want to capture that also, because before turning it off, at least turning off action will be captured, right? So I will uh, check for any such configuration changes also through the database. And then like contextual and temporal anomaly, like what IP address this user is coming from, whether it's allowed or not, what is the role that he is kind of using to do that activity. So for example, a person in HR, if he's trying to do some activity on finance database, then it should flag it out. Or again, the off hours login attempts or any query attempts, we need to be able to flag. And then based on all these different dimension, assign a score between critical, high, medium, low, or it's a safe activity. So this is the prompt that we use, but it depends on your organization, your context, and then you have to adjust it to make it appropriate for your use case. So let's just try to analyze that log. So I'll do Python 3 analyze. This time we'll use data plane audit log, right? And again, it will kind of um, create a HTML dashboard, which we'll be able to see. It has started analysis, and this is that dashboard. So it will analyze all the thing is that, through the AI and the scripting and programming, we can instruct it to ignore the, certain other commands or normal login attempts by root. Let's say we don't want to um, audit, or we don't want to keep a tab on internal activities, so we can set the script or the AI, we can say that ignore everything that goes on in the information schema activities, so that those are like noise. We don't want to focus on the noise, we just want to focus on the signals. So we I have already done that. So there are certain activities on the logs that initially we got to see. Let me just see here. Okay, I think we removed the other activities, but if there are, yeah. So before, I can again show it to you here. Yeah, so there were entries like this, if you remember. So these are nothing but the results of the earlier queries, and there are hundreds of such activities. It will keep on repeating, and if we spend time on each one of them, then think that how much time it will go. But since we know from the pattern that okay, these are not useful, we have said that in the script that while analyzing you don't have to focus on that, so you remove those lines from the audit log. So that's why they got removed, and it just kept on the real files, and now it is analyzing through our database AI. So what it did is, let's see from the bottom. So first command we ran was like use credit card, right? So it said that okay, it's a low risk. Why it's low risk? Because it's a standard database context switch with no malicious payload. However, the combination of root user accessing a sensitive financial database warrants a monitoring of subsequent queries. So it understands that okay, we didn't tell that credit card is a something special or something holding certain key information and privileged information. Just by looking at the name of the table or the database, it understood that okay, it's not a normal active, means there is a potential risk hidden in there. So it just says that risk is low, but we need to keep a watch on further activities. Then we did the select database. Again, it will say that root user doing the select database on credit card. So it could be database reconnaissance. Someone is just doing reconnaissance of the entire database structure. So we have to see more carefully. Commonly observed as a precursor behavior before the targeted data exfiltration. While the query itself is benign, the combination of privileged user and the sensitive database context warrants monitoring for subsequent suspicious activities. Then we did a select star from all the cards. So it will again say that, this is a high risk. Now we are, we are talking about the looking at the data. Like we ran the query and we could see that the username and their credit card numbers. So here it will say that, okay, root user executing unbound and select star against the table. So this constitute a high risk bulk extraction attempt targeting sensitive payment card data, which is, we have not instructed it, but it understands that it is against the PCI DSS payment and card industry, your data security standard. It's against that law and standard, and basically it is flagging that it is breaking that particular activity. Even though there is a limit applied of 1,000 records, it's kind of a risky because of our check is skipped as event type is query, not login, but basically it's trying to understand that okay, someone has at least viewed the list of credit cards. Then we did a standard SQL injection, right? So it quickly find out that okay, this is a classical authentication bypass SQL injection attack executed by root user against the user table in a credit card context, attempting to extract up to 1,000 rows of credentials and potentially sensitive PII data through unbound query. So the risk query, risk score has gone up to 95. And similarly for other SQL attempt, it has successfully identified. Same thing goes for granting broad privileges to this particular user, because granting user to uh, entire access to this particular database, which name is credit card, it's a sensitive information. So it is flagging that. And again, the last one where we kind of saved that file into the local disk. So we created a dump.85, right? So here as a hacker, I kind of dumped that username and password into my local disk. So it kind of flagged that root user executed unbounded this query, exporting sensitive PII financial data to CSV file disguised within the audit log directory. Classic bulk exfiltration pattern within the evasion characteristics. So identifying and uh, kind of showing it on the dashboard is one part, but you could you should ideally plug it into your alerting mechanism, so that as soon as this is detected, there is an alarm generated on the live, the person who is doing that. At the same time, you get an alert on your cell or in your email, or your alerting mechanism notification tool, that someone did that, and immediately you can take an action, not just as a afterthought, or let's say post analysis, that after 7 days you get to know from the newspaper or from the news line that so and so company got hacked and its data is available on the dark net or on the internet. So to avoid that, you can have this kind of analysis on the runtime. At the same time, you can alert it, and through the proper context, you can definitely improve your security posture tremendously. So yeah, so this is how we could see the live attack on the control side, control plane side, as well as on the database engine side, and we could analyze them on the real time. You can change the context on both the side as per your choice and use case, and it is pretty useful thing. So yeah, on the demo side, that was it. Just as a closing note, I'll say that even if you don't take anything else, but at least just to you know just as a closing note, I would say that if you are having logs, then don't just store them and process them very passively, or don't treat them as just a bunch of records. Just continuously pipe them into some kind of analytical system, and it should continuously process them, and it should be feeding into your alerting system or notification system if there are any risky events. And use AI just not to kind of detect certain things. You can also use it to filter out the noise, so that you can train it to kind of understand that, okay, these particular log lines are noise, and you don't have to focus on that, and just remove it from the audit logs, so that it kind of creates a new version of audit logs which is having the only the signals. And it will kind of reduce your fatigue, you reduce your time to understand those logs, and it will kind of help you in troubleshooting the real incident. So it can just by looking at the log, you can also you can automate it to kind of create a live security incident, and it will be just it will appear on your incident management system that there is a incident report, this person did this and that, and at this particular time here is the evidence. So possibilities are endless, right? So focus on decisions. You don't have to kind of spend time on finding issues. Your valuable time you should be spending on fixing them. So leverage AI capabilities that modern AI systems are providing, and kind of make our life easy. So yeah, uh, that was all there. So now we can spend few minutes that we have on Q&A. If you have anything, then Yukti, please let me know if there are any questions online.
Thank you so much, Jay, for this amazing presentation. Because honestly, because even I don't know on the topic, I feel so educated right now attending the session. So thanks so much. It was so amazing.
It was pleasure.
And
Yeah.
we have one question for you, which is open. It's from Shaji Nathan. They say that what is the minimum CPU mem storage requirement hash footprint needed to run the single store DB in a container? Can it run in embedded environments?
Uh, so I'm not sure about the embedded environments, but I can say that currently a single store demands 4 GB of RAM and 8 vCPUs on your to be configured on your system. And even though I have means the current system I'm using is a Mac, which is slightly more memory and CPU than what I just described, but that's what is um, uh, you know required to run that in your container environment or on your local machines.
Okay,
I hope
so
I could
we
answer
have,
that. Yeah.
yeah, that's
Yeah.
good.
Go ahead.
So we have one more question from Kaushik. So he says that what if AI misses a log entry or incorrectly flags a dangerous attempt? So how do we validate the result from LLMs?
So if I understand question correctly, user is asking that what if AI makes a mistake and how do we avoid that, right? So
Yes,
of
yes.
course, as goes with any AI system, so it's bound to make errors. So that's why when you create such systems, so there needs to be a right set of evals, what we call usually the in the standard software life cycle, we call it as a testing or QA. So there needs to be standard tests that has to be written to kind of figure out, means filter out all the edge cases. And again, this is kind of this is an addition to the your traditional CMs, which does the pattern based matching, but this will kind of give you leverage where traditional CMs will fall short of. So I would say that test it out on your internal systems, monitor it, and then keep on updating the prompt and the techniques, and the more your AI model will be trained on the data, that your historical data, the more accurate you will get the results. So that's how we should kind of rely on it. We should not, of course, just on the create a script and put it on the production. That's not how it works. You need to train it on your historical data. You need to monitor it, then tune it, and then go to the production. And again, for some time, you should, after regular interval, you need to keep check of new features being introduced, and those audit logs are, if whether those will be monitored or flagged by the AI system or not. So you'll have to keep updating your prompt and the entire logic of using AI to kind of detect such new feature related risk. So it's not one time done, and we can forget. We have to keep updating it.
Yeah. So, thanks. I hope that's the adequate
Yeah.
response because I mean, according to me, it sounded like a great answer. So, thanks. And we have one more question and a comment. So,
Yes.
thanks from Matthew. So, thank you. Great product. How do you scale it? How much can you scale it? And how many logs can you process in a second?
Right. So this is a kind of a preview, or rather internal project that I'm working on. So on the scale side, once we put it onto the cloud side, where we can leverage the uh, serverless functions to kind of analyze its on process. So I don't see the limit on the scalability side. I do see the limitation on the, let's say, AI inference side, or the token usage side. So that depends on the kind of the plan that you have purchased, or the model that you are using. So there is a possibility that you could use self-hosted LLM to analyze this thing, or you can use the offline LLM models and then train it on your data, so that many security since security, or how do I say that, security aware or security conscious companies, they don't prefer to send their data outside of their company's boundary, right? So they install it, local LLMs, and then they train it to on their data, so that this kind of activity they can be doing it on their environment with right amount of compute and the memory. So I don't see any limitation in terms of how many rows they are processing. It's like how you how you have kept your audit logs, how you have stored it, in what chunks, what format, and through how many parallel threads you can scan them and get it to your use. So uh, I don't see that cloud, since we have the AWS, GCP, or Azure clouds, that capacity or the capability should be enough to scale it to a hundreds of thousands of log entries.
All right. So seems like we don't have any more questions. So folks, if there's any other questions, Jay's email is there. You can always if there's
Yeah,
anything
reaching me out. Yeah.
email and like a lot my LinkedIn is also there, like you can always message me on LinkedIn. I'll send a follow-up email for anyone that missed the session. We'll send out a recording and all the resources that are attached with the session, so stay tuned for that. And my email would also be there, so if there's any feedback on the session, we are very open to it. Please feel free to send it my way. And we have amazing sessions that are coming up, so keep an eye out for a resources page that will also be attached to the email. And yeah, since we don't have any more questions, I think we can conclude the session. Jay, is there anything else you'd like to add?
No, thank you so much, everyone, for your time, and I hope there is something that interests you or was useful to you. So happy auditing.
Yeah. Thanks so much, Jay, for putting it together. And thanks for everyone that joined us from, I think, various time zones. So have a good day. Have a good night. Take care, everyone. Bye bye.
Thank you. Bye. Take care.